G'day brothers, welcome to the garage, and today I wanted to show you this thing. So this is a homemade hydraulic pull tester, and it looks a little bit different to your typical Hydra jaws. So I set out to design an open source pull tester that anyone can make. The parts for this cost about 200 bucks. Currently you can get up to about 40 kilonewtons of pulling, which is, not too bad. It's also relatively light and compact. It is a little bit heavy, but it still fits in a pack. I think it weighs about 6 kilos all up, so not too bad. So I've been testing with this a little bit lately, and you're going to see some of that in my upcoming videos where I do a bit of pull testing. Ooh, something went pop. But for now I thought I'd just do a whole video, show you how I made this, show you how it works, and that way you'll be able to build one for yourself if you're interested, or decide you want to spend $3 grand on a proper Hydra Jaws pull tester, something like that. So anyway, let's get on the bench and take a look. So the basis for this thing is a hydraulic hole puncher, and I chose that because it's surprisingly hard to find a pulling ram. This little guy, this pulls inside here, and it's actually for punching holes in sheet metal like this. It came in this nice little blow molded case with a bunch of dies and things that I haven't used for about 100 bucks, which was very nice. And I basically just settled on this thing because it's surprisingly hard to find hydraulic rams that are for pulling or that have a central hole. So this guy seems like a nice compromise. I'll just demonstrate what it actually does. So basically, as you pump, the center part there so the center part there retracts. You can tell it's a pulling ram because the hose attaches at the bottom, and when the fluid goes in, it's going to force the ram away from it. So it's only got a stroke of about 20 millimeters, which isn't the biggest, but it's all right for now. And basically cost was the main thing. This whole kit was 100 bucks. Otherwise, for a bigger pulling ram, you're looking at, $300-400 bucks just for the ram. For some reason, this is a popular enough kit that they offer it for real cheap. So it comes with these draw studs, which are basically just real big bolts. They screw in there, and then you screw a die on. So it was important to check the thread. Thankfully, Vevor actually published what thread this thing was, because that meant I could actually just go and buy other components. In this case, it's an M20 fine thread, so you can buy other stuff. It's not the most common, but it just means you can actually go and buy other things like that, and then just screw them right in. Luckily, this particular thread seems pretty common for higher load kind of things like pneumatics and stuff. So it's pretty easy to find rod ends and other things that have that sort of thread. So if you want a clevis, yoke, clevis, whatever you like calling those things, it's easy enough to just, screw one of them on, screw that in there, and then that forms the basis of your puller. Now I like having it small and compact, so I actually prefer to have a shorter clevis like that. So this is just one that I've trimmed down because this thing's only got a 20 millimeter stroke, and I don't want really big long legs on there. So you can do that. It takes a bit of drilling though. That's a lot of metal to drill through. But before those parts arrived, I found out that this thing off my winch is actually the perfect size to fit on there. So I basically got a bolt of the M20 fine thread, chopped it off, and then drilled a hole through to apply some linch pins or bolts or whatever. Now, drilling through that much metal isn't easy without a drill press, so I won't bore you with the details. But yeah, it's not the straightest hole. But you know, that's something you can also do. Now this bolt interface is a bit of a tricky thing to design because I did want to go a cleaver yoke style one, so it would fit over the bolt and then give I guess a nice pull to it rather than have something say next to it. So this seems to work okay. You can get these pins from the hardware store, and they do bend. I think that's 9mm or something. But you know, something like that works fine, but it is a bit tricky. It's fine with the Petzl Kerr hangers to fit that in there, but some of the other hangers, it doesn't really fit in nicely, so you've got to do a bit of fiddling. So if you do struggle to get the cleaver style thing to fit over your bolts, you know, you could always just try something like this. So something like that is going to be probably easier to apply, but it's too long for my purposes. So I'm going to keep experimenting with that. I think that's going to be the way to go, but I just got to find the right pieces. So I think something like this, so I'm looking for an eye bolt, something like that, not too long, and ideally without this bearing inside here, like this fisheye thing. So something like that would be ideal. Or if you have access to a drill press, you can always just drill through there and then use one of them. So the base plate, this is just a piece of old scrap plate aluminium that I found. All these little holes are unrelated. I just drilled a 20mm hole through the middle and then 12, 12, 12. Got some, these are cup head bolts. I thought having little feet would be fine, but you know, it probably doesn't matter. And those are 150mm long. So currently it's about that high, which seems, you know, high enough. I don't think it needs to really be any higher, but that's my reason for wanting to keep the actual pull arm shorter, because if we're looking at something like that, that is, you know, that's a bit more height, and then you'd have to jack it up again. So anyway, I'm trying to keep the pull arm shorter just because the legs are currently short, and I'd like to keep them, you know, shortish. I don't want these getting too big and out of control. So these are currently M12 stainless, so pretty solid, pretty resistant to bending. Obviously it helps with the bending if you actually watch it. I'm watching the pressure gauge, so I don't normally see what's happening here, but that's okay. Easy enough to just stick some new ones on if you need to. I probably will go thicker, maybe a little bit longer too in future, but for now, you know, it's fine. It's a little bit wonky, but you know, it's getting me the data I need. So to use, we just insert the draw stud through there, and then screw your life away, because these fine threads take forever. And that's basically it. You know, add a pin through the bolt there, and that is basically the pull system. So if all you need is a bolt extractor, something that can pull out bolts, even, I mean, old dodgy ones, this will do it, no worries. Even very strong ones, this will, you know, get there in the end. So, you know, you can just stop there. To actually get the data out of this thing, the force, you need a pressure gauge. So this, it was, you know, tough, but now that I know how, straightforward enough. Basically, you just need a vise. You can use a wrench on these things, but basically the fittings are just so tight. You need to put this whole thing in a vise and turn it, or get a really big spanner on there. Okay, so I actually had to stick that nut in a vise, wouldn't work otherwise, and I think I've managed to crack it. Oh yeah, very nice. Jesus, that thing was tough. Cool. And this one here, again, was the very cheapest I could find that still did the job. It's got a peak measurement, so that's what you really need, is the peak. And it's got a few functions, it's got backlight and stuff, so that's all right. It was pretty cheap, 60 bucks or something like that. And as you can see, the hose is big and stiff, so it's a bit annoying. But anyway, if we want to do it cheap, it's going to be a bit annoying to use. So the gauge thing, I actually got one of these assemblies. So this had the right thread. I was able to measure up the right thread after the whole pump thing arrived, because it didn't say what size thread that was. So I had to do it in stages, you know, buy the puller, measure the thread, buy this, you know, measure this thread by the gauge. So, you know, again, if you want to do it cheap and the manufacturers don't tell you, you got to be a little patient with these things. Okay, so if I just give it a bit of a pump, you should be able to see this is withdrawing. Zero that. So there you go, now it's bottomed out, so it's done its 20 mils there, so that'll shoot right up, and then there you go. And that's basically it. So it was like 100 for the puller, this was 30, about 60, and then, you know, a few bucks for all this other stuff here. So all up about 200 bucks, 250, something like that. Very cheap. So I'm pretty impressed with how this goes. But obviously there are a lot of improvements to be made. So one thing I would like to improve in future is I would love to get a Bluetooth pressure gauge. I haven't been able to find one, but a Bluetooth pressure gauge would be awesome to have, because that means you could watch the data on a screen somewhere, record it, you know, it'd be great. So if you've ever seen the Talk Test channel, that's basically the magic there is, you know, it's just a Bluetooth pressure gauge. That does all the measurements, plots them out beautifully. You know, that'd be great to have. But for now, we're just stuck looking at this. I would also love to get a longer hose. So this is only a meter. A meter's a little close to be to something that's about to go pop. I'd also like to get some quick couplings so you can just plug and unplug them. And you can also twist the hose around, because this is really rigid and it's hard to actually orient things correctly. But yeah, probably the biggest improvements I'm going to be making are to the legs and stuff like that. So maybe a bigger, probably not a bigger plate. This one's holding up all right for now. Probably bigger legs. I'll probably go M14, maybe even M16 on there. Maybe a bit longer, so I have more choice of stuff that'll fit underneath. I do think that this sort of combination of pulling hardware is going to be better than what I'm currently using, more versatile. So I would like to find a shorter one of these, or maybe cut that, or even ideally just, you know, get a bolt. Ideally just get a bolt and, you know, drill a hole through there. That would be the best thing, but a bit tricky to do probably. Other than that, the RAM itself, now for, I think the cheapest I found is about 300 bucks. You can get a bigger RAM that's a hollow one with a hole all the way through. So you can stick whatever bolt you want all the way through it. You can get a pull of 50 millimeters, which is probably fine. Now those ones do weigh about 6 kilos by themselves. So I'm not too keen on lugging one of those around, but you know, maybe if we had a home-based test rig, maybe that'll be the way to go. Otherwise, feel free to grab one. There are a variety of other ready-made kind of solutions like that out there, like valve pullers. I don't know what the hell valves they are in diesel engines or something. They seem to be the right kind of rig, much bigger, but they are a bigger pump, bigger RAM, a bunch of big long draw studs. You know, if you wanted to get one of them, maybe that'll serve you well. But if you're spending, you know, $600-700 bucks, I figure, hey, why not just, you know, save up a few 600-700s and then buy an actual proper Hydro-Jaws testing rig or something like that. So anyway, it sort of gets to a point where you'd be spending so much money on janky homemade stuff, you may as well just buy the new one. So anyway, I'll leave that one up to you. All right, and the big, most important thing, once we've got our pressure gauge on, we've got to calibrate. Now, the biggest and most vital part of this whole procedure is the calibration of this. So how does a pressure sensor actually tell you the force? Well, it's because due to the magic of, you know, definitions, I guess, pressure is force by area. So if you know the area that the pressure is acting on, you can work out the force. So simple as that, right? Well, sure. So unfortunately, I was not able to find any information on this particular cylinder on the inside. So I unfortunately had to crack it open and measure myself. I really tried to avoid that because, you know, I don't know what's in here. It's oil. It's full of oil, obviously, but I don't want to get involved with all that. So I did try to just see if I could get an idea, like a rough calibration using my load cell on my high lift jack.
Bugger.
And it broke the jack. So anyway, I had to dive in and do it. Now, there was no information whatsoever about opening one of these up. There are a lot of videos on YouTube about opening up other kinds of cylinders for measuring their surface area, doing this exact thing, but not this exact one. So I had to, look at a parts diagram, kind of try and work it out. And it turned out, yes, basically there's a giant spring inside here, and you just have to unscrew the top very carefully. I held this in a vise and had it kind of, sitting so it wouldn't spring off and hit me. And I was able to get that off and then measure up the actual cylinder head itself inside there. Ah, 50 millimeters. Are you fucking kidding me? So we ended up with a 50 millimeter outside and a 30 millimeter inside. So just worked out the area of those two circles, subtracted it out, and it turned out to be about 12 square centimeters of surface area that the pressure is pressing on to make that ram move. So this thing tells you it's currently on kilograms per centimeter squared. So easy enough to do, 69 kilograms per centimeter squared by 12 centimeters squared. There you go. Enter that into a spreadsheet. You can convert to kilonewtons as well if you want, and Bob's your uncle. There you go. That's the calibration. So that was a bit of an ordeal, and it's also, and I'm also the first one to actually document that. So I'm going to do a whole video on just opening this thing in case anyone else out there wants to see it. But for now, if you get this exact cylinder, this SYK8B1, you don't need to measure it. I've already measured it for you, so no need to worry about that. So I guess in summary, she does the job for now. Like any product, it's a work in progress. That's how these things go. It's pretty good for a $200 thrown together job. Little bit annoying. Got to jack up the legs at least once during every pull because 20 millimeters is just not that long. But other than that, I mean, it's great. If you are looking for something that can just put tension on something that's pretty light and portable, this is the way to do it. If you want big spectacular, money shots of stuff breaking, well, this can do it too, but it'll just take a bit longer. So some advantages of this is it's small, self-contained, fits in your pack, pretty light, pretty cheap, as cheap as I could possibly make it. Really, the only tools you need for this are a vise and a drill. You probably go without the vise if you really needed to. There are other ways of holding things down. Another big advantage of this is it's self-contained. So that is the whole pulling footprint. And that means that you don't need to actually have an anchor point. You don't need to have trees or something to anchor, say, a pulley to. So it's all right here. So that means a big advantage of this system is that you can test small test pieces. You can just test individual rocks or small concrete blocks or something. You don't need to pour concrete in a big slab. You don't need to find a big boulder. You don't need to go and damage the actual crag that you're climbing at. You can just find a few rocks and test the rocks as well, as long as they're representative of the stone. You can even take the rocks home and test them on a rainy day like I've been doing. So that is a real big plus. So it also pulls directly in tension, which is nice. But then that's a disadvantage as well. It only pulls in tension. It can't do radial pulls, but I'm sure if you wanted to work out some kind of sideways sort of deal, you'd be able to pull that as well. And yeah, disadvantages are, it's a bit janky. It's got a small stroke. You might just need to, I just bring some spare legs and replace them as needed. As you can see, I haven't actually replaced these ones yet, but that's fine. So disadvantages, we've already kind of covered that. The legs themselves, you probably want maybe bigger legs. I've got spares, but I haven't actually replaced them yet. I've been doing a fair bit of pulling and just kind of, rotate them back so they bend back straight kind of thing. So you might want to put bigger legs on there. Obviously the short stroke of this thing is, you know, not great, but you know, the next biggest pull cylinder is something like 6 kilos and it's about this big. So, and it'll cost you more than this whole thing. So I'm more than happy to live with a short stroke for now. It just means you got to wind the legs up once or twice as you're pulling. Yeah, the hose is, you know, not great. I do want to, you know, get a longer hose on there. That about covers it. But I do just want to end with a safety note. We're dealing with high pressure stuff here, and we're dealing with cheap and sort of modified high pressure vessels. So you do want to be careful. You know, hydraulics, it's pretty simple. You know, they wouldn't be selling consumer products like this if it was super dangerous, but just be aware that, you know, if you've got damage to the couplings or the tubing or whatever, you can get oil squirting out. If you want to know how bad that can be, look up hydraulic injection injuries on Google. Don't be squeamish. But, you know, we got tension on the bolt here. We got pressure inside here. Yeah, it's not without its risks, I suppose. So if you do want to do this sort of stuff, just go and educate yourself about that. And hydraulics can be a little bit fiddly otherwise. So for instance, this is slightly tilted downwards because the oil in here naturally needs to flow to the pump before it can actually go into the cylinder there. So yeah, you can. I have been able to use it in different orientations, but in general, you know, you got to keep it sort of downwards. But that's not been the biggest thing. The main thing is just the pipe's a bit too short. I feel a little bit too close to this. I don't think we're really, you know, reaching the pressures that are going to be popping this, but because I've actually done my own threads here, you know. So yeah, just, you know, you're messing with pressure and tension, so just be aware of the kind of risks that come with that. The main thing is, yeah, I'd be worried about springing leaks out of maybe damaged hose or anything like that, so just keep an eye on that. Otherwise, you know, I'm pretty confident. This is super cheap stuff, but also, you know, guys are using this all around the world every day. I really don't think it's going to be that hazardous for you. So I guess that about covers it for now. You know, just keep an eye out. You'll see this in my upcoming videos. And as always, let me know what you reckon. If you've got a better way to do it, cheaper way to do it, whatever. But yeah, you know, spread the word. We're a community effort here. I wouldn't be doing this if it weren't for you guys, all 10 of you. So there you go, guys. It is obviously still a work in progress, especially down this end. I do want to improve that a little bit. But for now, I figured that was okay to just, you know, share it with you in case, you know, anyone wants to make one of their own. But yeah, it fulfills the requirements I set out, which was, you know, a cheap, open source, readily available kind of bolt tester that other people could make. So, you know, there you go. Publish the recipe now. Feel free to build one. Let me know how it goes. Improve on it. Let me know if you find better, you know, cleavers components or anything like that. And anyway, scratches later. Happy pulling. Pull on. Get oily. Get hydraulic. Insert catchphrase here.